Let's look at how we can do simple linear regression in Excel. Well, let's talk about what we want to calculate first of all. Suppose we are hiring a bunch of engineers and we have developed a cognitive ability test that we believe will predict how well these engineers will perform. So we've got a bunch of data on engineers that we've already hired, and so we have their performance data. So we have in this table, we have cognitive ability and performance. And our goal is to create an equation that allows us to predict performance, which we'll call y, for a given value of x, which we'll call cognitive ability. And the form should be in y equals bx plus c. Now, you might recognize this equation from algebra. A lot of times it's in the form of y equals mx plus b. We've got the b is going to be the slope of the line, and the c is going to be the y-intercept. Well, the way that we're going to do this is we are going to uh, uh, use we're going to make a scatter plot, and then we're going to add a trend line to it, which will give us an equation. I think we'll also calculate R with data analysis as well. In fact, why don't we even start with that? So let's go to our data set, and that's going to be down here. Here we've got our data set. So let's calculate the correlation between these two variables first. So we go to data, data analysis, choose correlation. Okay, input range is going to be the entire table, including the labels in the first row, grouped by columns, labels in first row. Output range, let's put it down here. Oh, look at that. I forgot to, the cursor automatically went to the input range. So let's input the correct input range again. Now I'm going to click into the output range down here, and I press OK, and it gave me, and let's get rid of some of the decimal points. There, we have this correlation between cognitive ability and performance is 0.86. Well, that's really high for a performance prediction, but if it works and that measures exactly what the engineers are doing, then that's a pretty important predictor of success. So let's get an easy way of doing linear regression when there's only two variables. I can go put the I clicked into the table. I go to insert and I create a scatter plot. And there I've got a scatter plot. Now let's look at things here. It looks like we've got things all grouped over here. That's interesting. Let's see if we can change the axis, the y-axis a bit. So I'm going to go to one of these symbols will have something chart element. Oh, we want axis titles. Let's click those. Grid lines. Yeah, we don't want any grid lines. Legend, we don't want a trend line. Yeah, we want a trend line. And what else do we want on a trend line? More options. Let me move out of here. More options. We want display the equation on the chart and get R squared. That will be very useful. Let's see, what else can we do for the, I want to change the axes. How are we going to get the axes? Line, automatic, color, transparency, width, shadow, soft edges. Trend line name. Now this is all about the trend line. Oh, let's try something besides trend line options. Horizontal axis. That's what we want to change. Vertical alignment. No, it's not the vertical alignment. The bounds. Okay, there it's set from 0 to 160. Let's change that to 100 to 140. And that will be good. That's a lot better. We can move the linear equation out of the way. We can put the axis title. This is going to be cognitive ability. Hope I'm spelling that right. That would be horrible to spell cognitive ability the wrong way. Cognitive ability. Yep. And then over here, we'll put performance. And the title, performance of engineer, job performance, performance ratings. Let's call it performance ratings of engineers. Okay, so now we've got a nice chart of that. Now let's look at what we have. We've got the equation y equals 0.0741x minus 7, basically. So the x is the cognitive ability and the y is the performance. And that equation gives this line, and which has a correlation of 0.86. So that's a pretty strong correlation. This is a pretty good predictor. And the total R squared is 0.732. That means that 73% of the variation associated with performance is predicted by cognitive ability. That means there's another 27% that comes from someplace else, so it's not a perfect predictor. So let's go back to our PowerPoint here and talk about, so what does this actually mean? So we're rounding things off. We've got our equation. Let's make this a little bigger. Y equals 0.074x minus 7. So that means our slope is 0.074 and our y-intercept is minus 7. So that basically means to estimate an engineer's performance from his or her cognitive ability, you take 7.4% of his or her ability score and subtract 7. For example, if they have an ability score of 116, you plug it into the equation and you would get a performance of 1.58 on this 1 to 4 scale, which isn't very high. But this is how we do regression with one single variable, one single predictor. The predictor was cognitive ability, and the predicted variable was performance. We used the trend line tool in the scatter plot and got this simple equation to be able to predict the y variable performance from our one single x variable cognitive ability.